Hello students, in today's class of Advanced Construction Technique and Equipment, we are going to start a new chapter, that is earthquake resistant construction. The contents of the chapter are introduction, the terminology for earthquake engineering. Next we will discuss about earthquake, the seismic zone and measurement of earthquake, general principle for improving earthquake resistance in building, effect of structural irregularities on performance of RC buildings during earthquakes, the dynamic characteristics of building. So let's begin this chapter with the introduction. To avoid a great earthquake disaster with its severe consequences, special consideration must be given. Engineers in seismic countries have the important responsibility to ensure that the new construction is earthquake resistant, and also they must solve the problem posed by existing weak structures. Most of the loss of life in past earthquakes has occurred due to the collapse of buildings constructed with traditional materials like stone, brick, adobe, that is a kacha house, and wood, which were not particularly engineered to be earthquake resistant. In view of the continued use of such buildings, it is essential to introduce earthquake resistance features in their construction. The problem of earthquake engineering can be divided into two parts. First, to design new structures to perform satisfactorily during an earthquake, and second, to retrofit existing structures so as to reduce the loss of life during an earthquake. Every city in the world has a significant proportion of existing unsafe buildings which will produce a disaster in the event of a strong ground shaking. Engineers have the responsibility to develop appropriate methods of retrofit which can be applied when the occasion arises. The design of new building to withstand ground shaking is prime responsibility of engineers, and much progress has been made during the past 40 years. Many advances have been made, such as the design of ductile reinforced concrete members, method of base isolation, and methods of increasing the damping in the structures are now being utilized for important buildings, both new and existing. Improvements in seismic design are continuing to be made, such as permitting safe inelastic deformations in the event of very strong ground shaking. A problem that the engineer must share with the seismologist or geologist is that of prediction of future occurrence of earthquake, which is not possible in current scenario. Earthquake resistant construction requires seismic considerations at all stages, from architectural planning to structural design to actual constructions and quality control. Problems pertaining to earthquake engineering in a seismic country cannot be solved in a short time, so engineers must be prepared to continue working to improve public safety during earthquake. In time, they must control the performance of structures so that effect of earthquake does not create panic in society and its after effects are easily restorable. To ensure seismic resistant construction, earthquake engineering knowledge needs to spread to a broad spectrum of professional engineers within the country rather than confining it to a few organizations or individuals as if it were a super specialty. Next, we shall discuss about the terminology for earthquake engineering. First one is focus or hypocenter. In an earthquake, the waves emanate from a finite area of rocks. However, the point from which the waves first emanate, or where the fault movement starts, is called the earthquake focus or hypocenter. Next terminology is epicenter. The point on the ground surface just above the focus is called the epicenter. Let me show you a picture so that you will get a clarity. So see, focus or hypocenter is a point where the earthquake waves are generated, whereas epicenter is the point on the Earth's surface directly over the hypocenter. Next terminology is a shallow focus earthquake. Shallow focus earthquake occurs where the focus is less than 70 km deep from ground surface. Intermediate focus earthquake occurs where the focus is between 70 km to 300 km deep. Deep focus earthquake occurs where the depth of focus is more than 300 km. Epicenter distance, the distance between epicenter and the recording station in kilometer or in degrees, is called epicenter distance. Foreshocks are smaller earthquakes that precede the main earthquake. Aftershocks are smaller earthquakes that follow the main earthquake. The magnitude of earthquake is a number which is a measure of energy released in an earthquake, and it is defined as logarithm to the base 10 of the maximum trace amplitude expressed in microns, which the standard short period torsion seismometer would register due to the earthquake at an epicentral distance of 100 km. Intensity of an earthquake at a place is a measure of the strength of shaking during the earthquake and is indicated by a number according to the modified Mercalli scale or the MSK scale of seismic intensities. Basic difference between magnitude and intensity. Magnitude of an earthquake is a measure of its size, whereas intensity is an indicator of the severity of shaking generated at a given location. Clearly, the severity of shaking is much higher near the epicenter than farther away. This can be elaborated by considering the analogy of an electric bulb. Here, the size of the bulb, that is 100-watt bulb, is like the magnitude of an earthquake, whereas the illumination at a location is like the intensity of shaking at that location. You can see this is a 100-watt bulb, so you can this is analogous to the magnitude of earthquake, whereas the illumination of the caused due to this bulb is analogous to the intensity of earthquake. Next terminology is liquefaction. Liquefaction is a state in saturated cohesionless soil wherein the effective shear strength is reduced to negligible value for all engineering purpose due to pore pressure caused by vibration during an earthquake when they approach the total confining pressure. In this condition, the soil tends to behave like a fluid mass. So basically, when the earthquake load is acted upon a saturated cohesionless soil like a sandy soil, so the soil at that place, it loses all its shear strength and it behaves like a fluid mass. So at that site, it is pretty very much likely that the structures constructed over that soil get collapsed. So liquefaction is very, very dangerous. Next terminology is a tectonic feature. The nature of geological formation of the bedrock in the Earth's crust, revealing regions characterized by structural features such as dislocation, distortion, faults, folding, thrusts, volcanoes with their age of formation, which are directly involved in the earth movement or quake resulting in the above consequences, are known as the tectonic features. Seismic mass, it is the seismic weight divided by the acceleration due to gravity. Seismic weight, it is the total dead load plus appropriate amounts of specified imposed load. Base, it is the level at which inertia forces generated in the structure are transferred to the foundation, which then transfers these forces to the ground. Center of mass, the point through which the resultant of masses of system acts is known as the center of mass. Center of stiffness, the point through which the resultant of the restoring forces of a system acts is known as the center of stiffness. Box system, box is a bearing wall structure without a space frame, where the horizontal forces are resisted by the walls acting as a shear wall. Band, a reinforced concrete or a reinforced brick or a wooden runner provided horizontally in the walls to tie them together and to impart horizontal bending strength in them is known as a band. The ductility of a structure or its members is the capacity to undergo large and elastic deformations without significant loss of strength or stiffness. Shear wall is a wall that is primarily designed to resist the lateral forces in its own plane. Ductile detailing is the preferred choice of location and amount of reinforcement in reinforced concrete structures to provide adequate ductility. In steel structures, it is the design of members and their connections to make them adequate ductile. So we shall end the session here, and in the next class we will discuss the other topics. Thank you, students.